Now discussing about new results, new formulas. See, previously we already discussed about these results, that 1 upon root x square plus a square. Integral of 1 upon root x square plus a square is log mod x plus root x square plus a square plus c. Now see, here I am putting a new result. Integral of root x square plus a square. Look the difference. Here it was 1 upon root x square plus a square, and here it is root x square plus a square. So its integral is x by 2, keep x by 2, root x square plus a square, keep as it is. Then say this is plus a square, so put plus a square by 2, plus a square, so keep plus a square by 2. Then log mod x plus root x square plus a square plus c. So this is a new result. Then we discussed this result, 1 upon root x square minus a square. That is, its integral was log mod x plus root x square minus a square plus c. Now similar result, integral of root x square minus a square. Integral root x square minus a square, it is equal to, see, here starting was x by 2. Similarly here starting is x by 2. Then keep term as it is, root x square minus a square. Then this is minus a square, so put minus a square by 2 log mod x plus root x square minus a square plus c. Third result, integral of 1 upon root a square minus x square. So it was sine inverse x upon a plus c. Now here I am putting root a square minus x square, root a square minus x square. So it is equal to x by 2 root a square minus x square. Then say this is plus a square, so plus a square by 2 and this term sine inverse x by a plus c. So see how to learn these formulas. There is connection with those formulas. Already we worked on these formulas. So here this is root x square plus a square, root x square minus a square, root a square minus x square. In all these three formulas, beginning is x by 2, x by 2, x by 2. Then whatever is, keep as it is. Then next is, say this is plus a square, so plus a square by 2, minus a square by 2, plus a square by 2. Then join that part. So this is the way to remember these formulas. Now we are doing questions on these results. Suppose question is integral of root x square plus 7. We want to integrate root x square plus 7. So you can find its matching with first formula. So this can be seen as root x square plus root 7 square. 7 is root 7 square. 7 is not perfect square. It is not necessary that this should be perfect square number. Now matching with first result by first formula, root x square plus a square, its integral is x by 2 root x square plus a square plus a square by 2 plus a square by 2 log mod x plus root x square plus a square plus c. So this is x by 2 root x square plus 7 plus 7 by 2 log mod x plus root x square plus 7 plus c. Second question. Suppose we want to integrate square root of 4x square minus 25. Square root of 4x square minus 25. Now to apply these formulas, here coefficient of x square must be 1 and here coefficient of x square is not 1. So what we do here, express this as 4x square is 2x whole square. This is 5 square. 4x square is express 4x square as 2x whole square. Now see, here we change variable. Putting here t, we can have pattern of this formula. Coefficient of x square must be 1. So here taking t, it will be t square minus a square. So we can have exactly that form. So now we take substitute. 2x equal to t. If 2x is t, then 2 into dx is dt. So dx is dt by 2. So it is equal to, this is equal to, now putting these values, I is equal to, so integral is, this is I, square root of, this was t, 2x is t, so t square minus 5 square. And what is dx? Dx is dt by 2. So dt by 2 came outside. So now you can apply first formula. Root x square minus a square. Here variable is different. So it is 1 upon 2. 1 upon 2 is coefficient and this integral has more than 2 terms. See, integral has 2 terms containing variable part and plus constant. So to put this value, we have to use here bracket. Without bracket, don't keep that value. Otherwise this 1 by 2 will be multiplied with this number and that number will be left without multiplied with 1 by 2. So 1 by 2 into, now its value is t square minus 5 square. So t by 2 root t square minus 5 square, then this is minus a square, so minus a square by 2. This is minus 5 square, so minus 5 square by 2 log mod t plus root t square minus 5 square plus c. Here close bracket because 1 by 2 is multiplied with this number. So value we have taken in bracket, 1 by 2 is coefficient. Now substituting value of a t, What is t? T is 2x. So now I am putting here 2x. So 1 by 2 into 2x by 2 square root of 4x square minus 25 by 2 log mod 2x plus root 4x square minus 25 plus c. So it is equal to, this will be cancelled, x by 2 square root of 4x square minus 25 minus 25 by 2 into 1 by 2. So 25 by 4 log mod 2x plus root 4x square minus 25 plus c. So that is application of second formula. Now third question. Suppose we want integral of square root of 1 by 4 minus x square. So it is, you can match with this formula. So here this is square root of 1 by 4, we can see as 1 by 2 whole square minus x square dx. That is, it is equal to, now root 1 by 2 square minus a square minus x square. So x by 2 root a square minus x square, then plus a square by 2. So plus, this is a square by 2 is in formula, a square by 2 sine inverse x upon a plus c. So it is equal to x by 2 square root of 1 by 4 minus x square plus 1 by 8 sine inverse 2x plus c. So this is the way of application of these three formulas. So these are more results and its application. Square root of x square plus 3x. See, if any quadratic polynomial is given inside radical sign, see, quadratic polynomials are given, then first of all we shall split up constant. We shall split up constant in such a way that one part of that constant becomes last term of perfect square polynomial. Say here, integral of square root of x square keep as it is, 4x keep as it is. Constant we are splitting in such a way that its one part becomes last term of this perfect square polynomial. So to make this perfect square polynomial, last term should be 4. Now it becomes perfect square polynomial. But we are given 6, so we cannot change value. So put plus 2. So it is equal to square root of x plus 2 whole square plus root 2 square dx. Now see, here we are getting pattern of root x square plus a square. Root x square plus a square. So here we take substitute. Take x plus 2 equal to t. So putting there t, we can have exact pattern of that formula, root x square plus a square. So if x plus 2 is t, then dx is equal to dt. So integral is square root of x plus 2 is t, so t square plus root 2 square and dx is dt. Now applying root x square plus a square, x by 2 root x square plus a square plus a square by 2 log mod x plus root x square plus a square plus c. Application of formula. Now putting value of t is x plus 2. So putting back here x plus 2. See here, sorry, I have done mistake. X by 2. Here 2 comes. Root x square plus a square, x by 2 root x square plus a square by 2 log mod x plus root x square plus a square. So now t is x plus 2 divided by 2 square root of value of t is x plus 2 whole square plus 2 plus 2 square is root 2 square is 2, 2 by 2 is 1 log mod t plus root x plus 2 whole square plus root 2 square plus c. So this is x plus 2 by 2 square root of, its simple form is x square plus 4x plus 6 plus log of modulus x plus 2 plus root x square plus 4x plus 6 plus c. T is x plus 2. So this is its required integral. Now see here, constant is 0. In this quadratic polynomial, constant is 0. So this is square root of x square plus 3x. Now last term is missing. So to make this perfect square polynomial, last term is middle term square upon 4 into first term. 9x square upon 4 into x square. So this will be 9 by 4. Adding 9 by 4, it will be perfect square. But we can't change value, so whatever is added, subtract same number. So it becomes square root of x plus 3 by 2 whole square minus 3 by 2 whole square dx. So it is root x square minus a square. We are going to get pattern root x square minus a square. But here there should be x. So to match with that formula, we take substitute. Take x plus 3 by 2 equal to t. So dx is dt. Dx is equal to dt. So integral is, putting here t square minus 3 by 2 square and dx is dt. So it is root x square minus a square. So by root x square minus a square, formula is x by 2 root x square minus a square, then minus a square by 2 minus a square by 2 was in formula log mod x plus root x square minus a square plus c. X by 2 root x square minus a square by 2 log mod x plus root x square minus a square plus c. Now putting value of t is x plus 3 by 2. So putting here x plus 3 by 2 x plus 3 by 2 upon 2, this is t, square root of t square. So x plus 3 by 2 whole square minus 3 by 2 whole square minus 3 square is 9 by 2 square is 4 into 2 8 log modulus t. T is x plus 3 by 2 plus square root of x plus 3 by 2 whole square minus 3 by 2 whole square modulus plus c. So its a simple form will be 2x plus 3 by 6, 2x plus 3 by 4 square root of. Now its simple form will be x, say this is here, its original form is x square plus 3x minus 9 by 8 log mod, this will be 2x plus 3 by 2 plus square root of x square plus 3x plus c. So this is required integral. Now say here, this x square term is negative. In quadratic polynomial, when x square is negative, then always we set negative perfect square polynomial, we set in second place. This is minus x square, so put here minus x square, then put plus 3x, minus x square plus 3x. Now last term should be, because first term has minus sign, with last term I keep minus sign, minus 9 by 4. But we are having plus 1 and we have taken a minus 9 by 4. So how much we should add here, that we have to calculate. So say here we need something plus minus 9 by 4, total we want 1. So something should be 1 plus 9 by 4. So this is 13 by 4. So I should keep here 13 by 4 dx. So it is equal to integral of square root of 13 minus 9, 4 by 4, 1, it's okay. Now this is 13 by 4 minus common, it is x square minus 3x plus 9 by 4 dx. So this is square root of, this will be now root 13 by 2 whole square, root 13 by 2 whole square minus x minus 3 by 2 whole square dx. Now you can see that here we are getting root a square minus x square pattern. So now we are taking x minus 3 by 2 equal to t. Therefore dx equal to dt. So integral is square root of root 13 by 2 whole square minus t square and dx is dt. Now application of root a square minus x square. So x by 2 root a square minus x square, then plus a square by 2 plus a square by 2 sine inverse x upon a plus c. Integral of root a square minus x square is x by 2 root a square minus x square plus a square by 2 sine inverse x upon a plus c. So that is, now putting value of t is x minus 3 by 2. So here x minus 3 by 2 square root of root 13 by 2 square, that is 13 by 4 minus t is x minus 3 by 2 whole square plus 13 by 8 sine inverse x minus 3 by 2 upon root 13 by 2 plus c. So this is equal to 2x minus 3 by 4 square root of, now say its simple form. Its simple form is 1 plus 3x minus x square. So its expanded form is 1 plus 3x minus x square plus 13 by 8 sine inverse 2x minus 3 by root 13, 2x minus 3 by root 13 plus c. It is required integral.